this is lab class 4, and in this lab class we will be talking about 3 important equipment which is impedance analyzer, we can also say LCR meter, we will see the difference, and we will also look at the micro manipulator. Okay. So, this lab class will be taught by my teaching assistant Arjun. And in this lab class what we will be looking at, we are looking at the micro manipulator. What exactly micro manipulator is, right. Now, if you have you know that if there is a piezo resistor that we have seen in the theory class, when you apply a pressure to a piezo resistor, what will happen, there is change in resistance, is not it. Now, if I keep a tissue on the piezo resistor, so assume that this my palm is a piezo resistive sensor and this mouse is a tissue. So, if I keep the tissue like this, if I apply a force on this tissue, then the amount of force the piezo resistor will it will transmit to piezo resistor depends on the elasticity of the tissue or the stiffness of the tissue, is not it. So, now how to apply this force, this tissue that I am showing, this everything is magnified version, actually we are talking about micro sensors and microchips, is not it. So, the tissue itself is about 5 millimeter in thickness, and we cannot just press with hand. So, we need to press uniformly, and the system that can be used to used for uniformly pressing this tissue with micro steps, we can attach an indenter which looks like a pen to a system, and that system is called manipulator, and when it can precisely manipulate this indenter onto the tissue by applying a force, right, then this manipulation, step manipulation in micron steps is called a micro manipulator. You are manipulating your indenter in micron dimensions or micron steps, right. This is your micro manipulator. The applications are vast, it's a costly equipment. Just look at that equipment when Arjun is going to talk about it. This is one example, you can use micro manipulator for many other examples. Now, one of the important problem that we discuss is the drug screening problem, right. So, if you have a given drugs, out of 3 drugs, which one you need to select for the given patient, is not it. So, there we will be discussing about a process called impedance measurement. Now, the current techniques are based on colorimetric or optical way of detecting, but how about we introduce one more modality, and that is your electrical sensing. And if you want to have electrical sensing and you want to see that for the 3 different wells integrated with interdigitated electrodes, and those well also have cells or tissues with ECM, which is called extracellular matrix, which matrigel is extracellular matrix, it acts as a extracellular matrix. Why we require ECM? Because the cancer or tumor cells or tumor is surrounded by ECM, and to replicate the same in vivo situation onto the in vitro platform, we are using this wells with interdigital electrodes. Onto the well we are placing the cancer cells or spheroids along with matrigel, and we are loading 3 different drugs. These tumors are from the same patient, and the gel we use the same quantity of gel, and when we load 3 different drugs. If the drug is effective, the cells would die, and the dying is called lysing, and that will cause change in conductivity. If that happens, what will we can measure this conductivity. Now, you cannot just measure resistance, because now you are looking at a matrigel which is a complex itself in nature, and you have the cancer cells, and that is why you cannot just measure resistance, you have to go for the impedance. Sometimes you also have to load media, because how you load drug is in media. So, it is not very simple, there will be double layer capacitance coming into picture when we are looking at the measuring of the electrical sensing, and this electrical sensing, that is why we have to use impedance modality or impedance analyzer to measure the change in the impedance of each chip. If the drug is effective, conductivity increases, impedance would decrease. If the drug is not effective, then the conductivity would not increase, because the cells would not lyse, and the cells does not lyse, then that means that the impedance would remain intact. So, we can see the change in the impedance, and that correspondingly we can correlate with the efficacy of the drug. Efficacy means the performance of the drug. So, in this lab we will be looking at how we can use impedance analyzer, and what can be the frequency sweep. It can be from 0 to 2 megahertz. omegas, we can have DC offset voltage of different value, right. So, Arjun will be talking about those aspects in the lab. Look at the lab class. Any questions, feel free to ask. Till then, you take care, and I will see you in the next lab class as well. Take care. Bye.
Hi, welcome to the NPTEL course Sensors and Actuators. In today's session, I, Arjun BS, will be giving you a glimpse of how to use an impedance analyzer as well as LCR meter for impedance measurement and how it is useful for the course Sensors and Actuators. So, what do you mean by impedance? Which is the first question that we need to address before going to the understanding of impedance analyzer. Okay. So, impedance is the opposition that current faces when it flows through a circuit or component or any of the component in a sensor or any of the system. Okay. So, we will be dealing with impedance first, and you must also have heard of resistance, that is having a similar definition. So, what is resistance? Resistance is also the opposition faced by electric current when it passes through a conductor, or based on this resistance we have classified materials, and we must have learned it in previous undergrad courses as well as during our schooling. So, based on resistance we classify materials as conductors, insulators, semiconductors, etc. And now you must have even heard of superconductors, and IAC had even made a breakthrough on this. So, what are these conductors and all? So, conductors conduct electricity and they do not show much resistance to the flow of electric current, right. And similarly, for example, the materials such as gold, copper, aluminum, etc. are good conductors of electricity. Similarly, we have insulators which oppose the flow of current such as rubber, ceramic and other things. And there are semiconductors also like silicon that you must have heard of it at different parts of your education. So, what essentially is the difference between impedance as well as resistance? Both have more or less the same definition also. So, the term impedance is used in case of AC circuits, that is alternating current circuits, and the resistance is the term or concept that we use mainly for DC or direct current circuits. So, what essentially is the difference between both, and why these terms are different, and why are these used in both of these different cases? So, first we will talk about impedance. Impedance have two terms, that is, or two parts in it, that is resistance as well as reactance. So, what I mentioned earlier is resistance, which is a concept that is used in direct current circuits, but in case of impedance that is being used in alternating current circuits, we have resistance as well as reactance together, and these two together contributes towards impedance. So, impedance is something similar to resistance in a DC circuit. Okay. So, what is the resistance as well as reactance in a AC circuit? Okay. So, resistance is nothing but the opposition that electricity or current faces when it passes through a circuit. So, opposition is created due to the fact that the electric current is composed of electrons, right, the flow of electrons. So, when the electrons pass through a conductor or a ionic medium due to a potential difference, you know potential difference is essential for the flow of electric current, right. So, this potential difference will create a flow of electrons, and when these electrons pass through the medium, they will collide with ionic lattice, and that causes resistance. So, due to this collision, some of the energy supplied across the electrodes or the terminals is lost as heat. So, we must have heard of Joule heating also, which is essentially due to this specific reason. Okay. So, when the electrons pass through a ionic lattice, it has resistance. So, what is reactance now? Apart from resistance, you must have also heard of capacitance as well as inductance, right. So, what is a capacitance? You must have heard of a capacitor also before. So, it is basically two plates may be separated by a dielectric medium. So, when we apply potential difference across it, the current starts flowing through it and the capacitor will charge itself. So, something like a battery. So, the thing about the capacitor is that it accumulates the charge. You must have heard of the equation Q is equal to CV, where Q is the charge stored by the capacitor, C is the capacitance, and V is the potential difference across the capacitor. So, Q is equal to CV. So, the property of the capacitor is such that when the current flows through it, it will charge automatically, and it can store a maximum amount of charge corresponding to its capacitance and the potential difference applied across it. So, at a point it cannot store any more charge and it will oppose or stop the current that flowing through it. So, in a DC circuit, what does a capacitor do? When the electricity flows through it, it will charge itself to a maximum level, and the potential developed in the capacitor will get ideally equal to the potential applied across it, and no longer the current starts flowing through it. So, that is how a capacitor works. And you must also have heard of inductor. Inductor is nothing but something like a coil. So, when the current flows through it, it will create a magnetic field, and this created magnetic field will create another back EMF. So, once the current flows through it, or the current that is flowing through it increases, the magnetic field strengthens, and at a moment the back EMF will be strong enough to oppose the potential difference applied across it, and the inductor will stop conducting current. So, this is how an inductor as well as capacitor works. So, in a capacitor, when charging happens, it will start resisting the flow of current through it, and also an inductor will oppose the current flowing through it once it starts creating a magnetic field. Okay, so, this is how a capacitor as well as inductor acts when current flows through it. So, consider a AC circuit. So, the current or the voltage applied across it will be fluctuating, right, maybe a sine wave or a cos wave. So, in that scenario, what happens is a capacitor, when the current flows through it, when an alternating current flows through it, it will charge as well as discharge. So, it will conduct electricity at a specific rate that varies according to the time, okay, or the phase. Similarly, an inductor also, its magnetic field increases as well as decreases, and even changes the polarity depending on the direction of current flowing through it in a AC circuit. So, an AC circuit will, since it is a sine wave or a cos wave or any other wave, has its own frequency as well as time factor if it is a periodic wave, correct. So, this resistance that is put forward by the capacitor or inductor is called as reactance. So, capacitive reactance as well as inductive reactance, and together both of them, if both of them are present in a circuit, it will together contribute to something called as reactance. So, reactance as well as resistance combine together to form impedance, and impedance and the reactance has two parts, inductive as well as capacitive reactance. And since and also the reactance is time dependent, and this reactance will put forward a phase change in the between the current and voltage flowing through the system. So, the impedance is also referred to as complex impedance at times, because it has two parts, okay, the real part called as resistance and the imaginary part called as reactance. So, this resistance as well as reactance both are there, real part is resistance and imaginary part is reactance. So, impedance have both magnitude as well as a phase or an angle. So, it is more or less like a vector, but coming to the resistance, it's just have a magnitude and no phase. Okay. When we talk about the term impedance, it is restricted to AC circuits, and resistance is restricted to not only only resistance acts in a DC circuit. Okay. So, I think you must have understood a basic difference between an impedance and resistance, and why impedance is a concept that is used in AC circuits and resistance is used in a DC circuit. Okay. So, now that you have understood something about impedance as well as resistance, now we will talk about the importance of impedance analyzer, that is the theme of today's session. Okay. So, impedance analyzer is a testing device that is used to, electronic test device that is used to measure impedance. Okay. So, measuring the impedance means we need to measure its magnitude as well as phase angle, right. So, before that I would like to tell that the unit of impedance is ohms. that is same as the unit of resistance, and it will also have a phase angle that is respected that is presented in radians or degrees. Okay. So both of these components are there. Okay. And as you know, the inverse of resistance is conductance, whose unit is mho or Siemens. Similarly, the reciprocal of impedance is admittance, whose unit is also mho or Siemens. Okay. This is the basic understanding that you need to know about impedance. Now we will talk about impedance analyzer. So it's, as I said, it's an electronic test device that is used to measure the impedance across any electronic circuit or component, and it is very useful when it comes to sensors and actuators. So why am I talking about impedance analyzer when it comes to a sensors and actuators course? We will talk about that now. Okay. Now you must have heard of a new device that is put forward by Xiaomi today in last 1 month or so. So it is nothing but something like a weighing scale. It's named as MI body composition scale. So it's something like a weighing machine over which we usually stand and measure our weight. So this device is something special. So it can tell you your weight, obviously, your body mass index, your fat content in your body, the muscle composition in your body, and so on. So how much data being presented to you has increased over from a ordinary weighing scale, correct? So how does this work? It will look something similar to or exactly like a weighing machine that you have seen before, but it has something like 2 or 4 electrodes, 4 SS stainless steel electrodes. So what it does is, when you stand on this disc or a weighing scale, it will send a small electric current through your body, which will measure the impedance of your body. Okay. So what it does is, it will send a small amount of electric current to your body, and it will measure the impedance across your body. So you know that your body will have water, all our body will have water in it, and most of this water is stored either in muscles or as blood itself, right? So the muscle content, as the muscle content in a body increases, the water present in the body also increases. So based on this, since water decreases impedance, the device will be able to tell us what is the percentage of muscle in our body, what is the percentage of fat in the body, based on this impedance measurement, as well as a lot of machine learning algorithms they have developed and using process data that they are obtaining related to impedance. Okay. So this is one application. Now I said how impedance measurement can be used in a body as such. Now come to a cellular level. We know that a cell will have cell wall as well as cytoplasm, right? So the cell membrane as well as cytoplasm. This cytoplasm has ionic solutions inside it. Okay. So what happens is, if we pass current through a cell, it will provide some resistance. Basically because there are ionic solution inside it, it will conduct electricity. At the same time, it will provide some small amount of resistance. At the same time, the cell membrane will act something like a dielectric, and which will have properties like a capacitor. So what happens is, when you pass electricity through or a small amount of current through a cell, it will have both capacitive as well as resistive effect, and hence if we measure the impedance across the cell, we will be able to know the properties of the cell. So if the cell ages or some other properties of the cell changes, something like for a bacteria or any other cell, we will be able to predict the cell properties. So impedance can be used as an extra modality to understand the properties of a cell or a tissue or something like that. Another application is, you must have heard of gas sensors. So these gas sensors recently uses a lot of different types of gas sensors are available. One of them is like metal oxide gas detectors or sensors are there. This will give you the quantitative data of how much gas is present in an atmosphere. Okay, so it can be alcohol detection or any other things like acetone or any other poisonous gas or something like that. So how does it work? So there will be a ceramic substrate on which an electrode will be fabricated. So over this electrode, we will be coating a metal oxide specific to a specific gas. Okay. So once this metal oxide is coated, if that gas is present in the atmosphere, then what the metal oxide does is, it will either absorb or adsorb these gas molecules, and maybe some small reaction happens on the metal oxide surface. So, measuring the impedance across these electrodes, since the property of metal oxide deposited it changes, we will be able to say the concentration of the gas in the atmosphere. So, this impedance measurement is a very good modality that can be used for different applications. Similarly, there will be pH sensors and other sensors that can be made using the same concept. Similarly, when it comes to actuators, the motors and the other devices we use have coils in it, so we can measure the impedance across it. So, when we are going for manufacturing of consistently same motors with the same torque and speed, it's always useful to measure the impedance to know the properties of the motor and whether they are consistent or not. So, now we will focus on how to use these devices. Okay? Yeah. So, now we will see how to use a impedance analyzer as well as a LCR meter. Okay. So, what we have here is a impedance analyzer by GW Instec. This is a Taiwanese company, and here what we have is a LCR meter. Okay. And here we have an LCR meter. Okay. So, what are these two? So, as I said earlier, an impedance analyzer is an electronic test device that is used to check a electronic circuit as well as a component or any of a tissue or whatever we have discussed earlier. Okay. So, whatever instrument or sensor that we are going to test, we call it device under test or DUI. So, a DUI will be connected across the probes of an impedance analyzer or an LCR meter, and we will measure the impedance across it. Okay. So, I will talk about impedance analyzer now. Now, to switch it on, so you can see how it shows. So, this is a GW Instec LCR 8100 series. So, you can see the digits over here 8105. So, the other variants of this 8100 series are 8101, 8105 and 8110. So, the last two digits shows the frequency range of a impedance analyzer. So, you must understand that the main key specifications of an impedance analyzer are its frequency range over which we can measure the impedance, because I already said earlier that the impedance is a function of reactance as well as resistance, and reactance depends upon frequency of the test signal, right. So, as we sweep through the frequency ranges, we will be having different values of absolute impedance. Okay. So, one of the key specification of the impedance analyzer is its frequency range. Second, another important thing is the accuracy of the impedance value or the absolute impedance that we can measure with it. So, we are using these precise instruments that cost lakhs, because we can measure the impedance very accurately even to the range of ohms. The third other parameter is the range of impedance values that we can measure with it. So, it can vary from 0 to a few mega ohms. And similarly, the fourth key specification is the phase value accuracy or phase angle accuracy. So, these are the four parameters or the four key specifications of an impedance analyzer: the frequency range, the impedance range or the impedance values that we can measure, then the accuracy of the absolute impedance, which consists of both resistance as well as reactance values, and the phase angle. So, if we know the absolute impedance and the phase angle, then we will be able to interpolate or calculate the reactance as well as resistance components also. Okay. So, that is the these are the key specifications of the impedance analyzer. So, here you can see letters written C, L, X, B, Z, Y, etc. So, C correspond to these are different modes we can select and for the measurement. So, C goes for capacitance, L for inductance, X for reactance, B for the magnetic intensity, Z for the impedance, and Y for the admittance. So, these are the different modes or measurement modes that we have in the impedance analyzer, and we can change them and do the measurement. So, here is where you will be seeing the measurement. I will be showing you how the measurements are done. Now, also here you can see that the potential difference that will be applied across the test sample and the frequency. Okay. Now, as in every instrument, measurement instrument, we have probes. Okay. So, what we have here 4 probes or connecting ports for 4 probes. So, I have here a cable and 4 cables over here, right. So, one is brown, red, orange and yellow. So, similarly, you have the colors here brown, red, orange and yellow. So, I am connecting it for you. Okay. Here you can see that 4 probes are connected. So, you will be, and you can see here there are 2 end effectors for this. So, using which we can measure across any electrode. But an electrode will only be having 2 ends, right. So, across which we can measure, and here also there are only 2 ends for this, but there are 4 cables out of it. What does it mean? So, you must have seen ammeter or voltmeter or any of the measurement device. There will be like 2 probes coming out of it, but here you have 4 probes coming out of it. So, these are basic, these kind of instruments using 4 probes are called 4 probe measurement or 4 probe sensing, etc. It is also called as Kelvin sensing. Okay. So, what is the difference between a 4 probe sensing and a 2 probe sensing? You can see here in the LCR meter, there are only 2 probes like an ammeter or a voltmeter. So, what is essentially the difference between a 4 probe as well as 2 probe instruments? So, you know that when we are going to measure the impedance of a instrument or a sensor that we have fabricated using a 4 or using 2 of these probes, we will be contacting it to the surface, right. So, then we will start flowing a small amount of current through it or applying a potential difference across it, and based on the V by I value, we will be measuring the absolute impedance, correct. So, to get the phase or the proper impedance with phase, we will be doing phase sensitive V by I ratio to get the impedance. So, in that scenario, when we go for the low resistance or low impedance measurement, what happens is due to the contact resistance between the probe tips as well as the device under test DUT, there will be a variation in impedance that we wanted to measure, and there will be loss of accuracy. So, a 4 probe instrument does something different. So, it will have both out of these 4 probes, a pair it will be called as force cables or force probes, and the other will be called sensing probes. So, what force probe does is, it will pass a current through the system or the DUT, and which will cause a potential difference to be developed. So, when this happens, the potential difference that is applied will be dropped across the DUT as well as due to the contact resistance. So, at the contacts there will be voltage drop as well as across the device. So, that contact resistance will be causing a huge voltage drop at some cases, especially when we are measuring devices with very low impedance. So, that error will increase and the measurement will be invalid. So, what we have here is a 4 probe, and in case of 4 probe, what happens is the current or the potential is applied across the forcing probes. So, the voltage drop will be happening across that one, and using the different sense probes, we will be measuring the actual potential drop across the DUT. So, we will be avoiding the contact resistance or the contact loss in the sensing. So, whatever value we will be getting will be free of contact resistance, and whatever impedance measurement we can get out of this will be perfectly accurate. Okay. So, that is the difference between a 4 probe and a 2 probe. 2 probe will be less accurate compared to the 4 probe measurement. So, in any of the measurements or instruments, the first step we need to do is, after switching on, we need to calibrate it. Similarly, in this case also we need to calibrate it first. So, I will be showing how to calibrate it. You can see here a calibration button. So, I am going to push the calibration button. So, there is another mode or another screen coming up. So, it shows OC trim as well as SC trim and measure. So, OC trim means open circuit trim and SC trim means short circuit trim. What OC trim does is, it will check whether the instrument is truly open. Okay. So, see these probes over here. So, they are not in contact. So, if they are not in contact, it means that the circuit is open. So, OC trim checks whether the circuit is actually open and calibrate according to that. So, I am pressing this F1 button corresponding to OC trim to calibrate it based on open circuit. So, it will ask you when I press the F1 button, that is open OC trim, it will which frequency range we have to test it. So, I am going to test it for all frequencies or F5 button. So, you can see that all frequency open circuit trim in progress. So, as that progress bar reaches the end, the calibration will be done based on open circuit. So, after this we are going to test for the SC trim or the short circuit trim. Okay. So, I am pressing the F2 button, but at that time we need to make sure that the probe tips are in contact. So, I am keeping the probe tips in contact. Okay, they are in contact now. So, I am going to give for all frequencies. You can see the progress bar moving. So, both SC trim and OC trim are done. So, now we can go back to the measurement mode. So, I have calibrated the instrument. You must have seen this extra probe. This is the ground. So, this is to ground the instrument to the reference for the protection. Okay. Now, I will be attaching these probes to the micromanipulator that we have over here. So, you can see here, this is the control for the micromanipulator and these are the two manipulators. So, I am going to attach these two probes to the micromanipulator. So, a micromanipulator is used for moving the manipulators at a micron range. Since we need to ensure the contact, it is very essential that we need to use micromanipulators and devices, precise devices like this for the measurement on the later stage. Okay. Okay. Now, I have attached both these instruments to the micromanipulator. You can see these are the controls for the micromanipulator and we can move it in X, Y and Z directions. Here you have the relative positions of the manipulators with respect to X, Y and Z. So, you can see here micromanipulator, this is the control for the micromanipulator and these are the manipulator ends or the end effectors. Okay. So, I have attached the probes here and here. So, we will be able to do measurements by keeping the electrodes under this and checking the instruments. Okay. So, you can see here the absolute values of the coordinates of the each micromanipulator end effectors. So, I can change between the two. There are two of them. We can individually control every one of them. See, you can see this one moving up and down, or you can see that this one moves up, and we can also translate them in Y direction as well as X direction. This is how you use a micromanipulator for this measurement. Now, I will be showing you how to use this micromanipulator and do a measurement. For this, since this impedance analyzer can be connected to a PC and we can retrieve data from this, we will connect this impedance analyzer to the PC now. So, what we have here is a micromanipulator setup and our probes attached to it. So, this is the control of the micromanipulator. Okay, so there are two micromanipulators we have over there, and this is the control. So, you can see a LED here which will show you which micromanipulator we have connected to the instrument now. So, it shows the yellow one, that is the micromanipulator on the left, and if I press this button that is used to switch between the micromanipulator, this red LED glows and it is connected to the right one. Okay, we can connect up to 4 micromanipulators using this controlling unit. You can see 3 knobs over here, 1, 2 and 3. These are used to control the micromanipulator. So, if I am controlling the one on the left, I am putting back to the orange mode or yellow mode. Then, if I am going to turn this knob is the Z knob. So, if you can see that if I am rotating this one, the micromanipulator is moving down. I will be showing how the control or the movement of the one of the manipulators here. So when I am rotating the knob over here, you can see that the micro manipulator is moving, right? It's moving down now. So this is the Z axis. Okay. So if I rotate it slowly, it will move very slowly. We rotate it fast, it will move very fast. So according to that, we can use the Z axis. Similarly, we can use Y axis and X axis. Okay. This is how we use a micromanipulator. Now I will be showing you how to connect the impedance analyzer to our PC. Okay. So since we have connected the PC to the impedance analyzer, now I will be showing you how to measure impedance of a real sensor. So what we have here is a microchip. So it will be a sensor. So what we have here is a microchip, and this is the sensor that we are going to test it today. Now we have connected the impedance analyzer to the PC. Now I am going to show how we are going to test a sensor that we have fabricated here and testing it with the impedance analyzer. Okay. So you can see on the screen, this is a microscopic image of the electrode we have fabricated. This is very small compared to this image on the screen. Okay. So you can see a big electrode coming over here and splitting into small electrodes, and we have a outer electrode also. This is what we call as an interdigitory electrode. Okay. So if we place a fluid over here, this fluid will cover the electrodes and we can measure the impedance of the fluid placed here. So it can be a bacterial sample or water or any other solution. Okay. So coming back to the real sensor that we have got here. Now we need to test a fluid on this chip or the electrode. So since this is a plane, we cannot hold a fluid there. So we have fabricated PDMS wells over this interdigitory electrode so that we can pour some fluid onto it. Okay. So this is that microchip that I showed you on the PC screen. It will have different electrodes inside here, and this one is the PDMS well. So now I am going to connect this interdigitory electrode to our micromanipulator with the probes. Okay. Now I have connected the microchip to the manipulator. I will be loading a sample solution into this chip right now. Okay, and I will show you the measurement on the PC screen as well as the impedance analyzer. After connecting the microchip, I am taking a micropipette and pipetting 50 microliter of salt solution to show as a test specimen, and I am loading it onto the well number 1 of the wells. Now we will be measuring the impedance of the well. Now I am going to show you how to connect the impedance analyzer to the PC. This is the software, it's called LCR. So you will be showing some connecting errors, right? It's because we had to select the communication port that is being connected from the impedance analyzer. So I have to close this. Then this is the connecting option. So you have to give the COM port to which the impedance analyzer is connected. In my case, it's COM port number 5. So I have to connect and exit. Now the impedance analyzer is connected and no error is being shown. So we are going to plot the impedance right now. So this is the plot mode. There are other options also, save and other things. So I am going to go for the plot mode. So this is the plot menu. So here you can see different options and the values that we can enter. So we can control all the features of the impedance analyzer using the software here. So here you can see the term level, which is where or the voltage that we are going to apply across the test sample. So here it is 10 millivolt. We can change it, but usually for biological samples as well as testing, we use it as 10 millivolt itself. Then you can see here a drop down having different options. It is to select whether you want to record capacitance, inductance, reactance or impedance, and even DC resistance. So I am going to select impedance here, and also we can select a second item to be plotted together. So when we select the impedance as one of the parameter, then the other parameter we have is the phase angle. So I am selecting that also. Then no circuit option is here when it comes to the impedance measurement. Now we have another option, speed of measurement. So, it is slow, medium, fast and maximum. So, depending upon the speed, the accuracy will also change. So, I am right now going to show you with the fast mode. So, now you can see here what all lines are visible, line 1, line 2, line 3 and line 4, which are of different colors. Okay. So, different colors means we can plot 4 different color lines. If we select all of this together, we can untick them if we need. So, you can see when we untick, it is changing over here, the y axis. So, if we are just measuring impedance, we can plot the sweep 4 times. If we are plotting both impedance as well as phase angle, then we can plot it twice, because we are using two lines each time. Now, here you can see the plot in an impedance analyzer is frequency or phase versus either impedance or phase versus frequency or the voltage. Here I am going to show you that we are going to sweep across frequency. We can also select voltage. So, under frequency, we can, our instrument, since it is 8105, we can sweep up to 0 to 5 megahertz. So, I am going to give the start frequency at 0 and say end frequency at 1, and here I am selecting the unit megahertz. You can select hertz, kilohertz or megahertz. So, this means that I am going to give a frequency sweep and measure across 0 to 1 megahertz. Here you can know the number of points across which we should do the measurement and save it. Since we have the option to export this data as Excel, so if we give 100 points, we can save 100 values between 0 to 1 megahertz. Okay. Now, we have connected the chip over there. Now, we will be connecting the measurement chip to the impedance analyzer. Now that we have connected the microchip to the impedance analyzer, I am going to start drawing the graph. So, there is the draw button and I am pressing the draw button now. So, it will start recording the data. You can see the plot over here as well as the value change over in the instrument. So, here you can see the red one shows in the phase and the green one showing the impedance value. Okay. And at the same time, you can see in the impedance analyzer the value being changed as well as the phase value. Okay. So, as I said, the impedance is a function of frequency of the test signal. The impedance value, as you can see, was changing. Okay. So, this is how we measure the impedance of a sensor using impedance analyzer. Now that we have got the plot, we can draw again so that we can take the measurement over, or also we can export this file to the Excel. When I press this button, an Excel sheet will be popping up. So, it will have the data, all the data that we have recorded as of now. It will have both frequency, the impedance value and the angle. So, this can be saved for future reference and for plotting and analysis at the later stage. This is how we use impedance analyzer for the measurement of impedance and for the testing and calibration of the different sensors and components that we will be fabricating. So, you have seen how a impedance analyzer works. I also talked about LCR meter, the L for inductance, C for capacitance and R for resistance. This is an LCR meter. This is a two probe device. So, it will have lesser accuracy than that of the impedance analyzer, and it does not have too much frequency sweep that as we saw in the impedance analyzer. So, I am pressing the switch power button. So, you can see the display turning on. So, using this probe, you can actually do the measurements. So, you can change between the different modes as L, DCR, C, R, etc. Okay. That is how. Now, if we are connecting these probes across the measurement or the DUT, we will be able to measure the data and we will be able to see this real time on the device. This is how we use a LCR meter. Okay. Thank you.